Okay, first part of chapter 3, relations and functions. Today we're really going to look at relations. We'll look at functions when we get back from fall break. Okay? So if you don't know what a relation is, here's the definition. A relation is a set of ordered pairs. That's all it is. A set of ordered pairs. Notice it says set. Set's highlighted, bolded. I underlined it. When we're dealing with a set, sets need what we call set notation. So we use these little curly Q brackets to denote a set. So I've got an example up here. I've got a set of ordered pairs. Got my curly Q brackets, and the ordered pairs are just listed in those curly Q brackets. That's a relation. Okay? Questions on what a relation is? All right. Can I move on?
No.
Okay. Am I good to move on? Yes or no? Okay. Okay, let's talk about domain and range a little bit now. You guys heard of domain and range before?
Yes.
Make sure your heads are up, please. Okay, the domain is just my set of x values. So which value comes first in an ordered pair, x or y? X. And a y comes second. So, domain is my set of x values. The set of first values in the ordered pairs. So for my example up here, my x values are 1, -2, 3, and 5. So my domain is just the set of the numbers 1, -2, 3, and 5, because that's my set of x values. Everyone see that?
Yep.
Another way to write domain is right here. This is domain equals the set of all real numbers x, such that, if I've got a vertical bar right there, that just means such that. Set of all real numbers x, such that x equals 1, -2, 3, 5. That's just another way to write my domain. Okay? So any questions on domain? It's my set of x values. We can also call it my set of inputs. When we talk about functions, we'll talk about input, output. My x values are my inputs. So it's my set of my inputs also. Okay. If domain is my set of x values, what do you think that makes my range?
Set of y.
My set of y values. Can also be called my solution set. Because when I have inputs, I have outputs that are my solutions. My y's are my outputs. So it's my set of outputs, my solution set, set of y values, set of second values in the ordered pair, my set of answers. So up here, got the y values 2, 1, 1, 3. So up here, how many times do I have 1? We got it 2 times, right? 1 as a y value? Just 2. Did I write 1 twice in my set? No, because 1's already represented, so I don't need to write it a second time. It's a part of my y values. So I only have to represent it once. Okay? So this is my range. Once again, I can write my range another way. range equals the set of all real numbers y, such that y equals 2, 1, 3. Are there any questions on domain and range? Does that make sense? Domain is just my x values. Range is my set of y values. Not too bad? Can I move on?
No.
Okay, I'm waiting. So relation's a set of ordered pairs. Within the relation, my domain is my set of x values. My range is my set of y values. Okay, am I good? Give you a little bit longer. Okay, I can come back to the slide if I need to, but I'm going to move on. Okay, there's multiple ways to express a relation. We've already seen the first way as a set of ordered pairs. So there's my example right there, 1, 2, negative 2, 1, 3, 1, 5, 3. That's one way to represent a relation. A second way I can represent a relation is a table of values. You guys have hopefully seen a table of values before. But in a table of values, I just have an x column and a y column. Does this kind of look familiar? What's my first x value? 1. What's its corresponding y value? 2. Second x value? Negative 2. Corresponding y value? 1. Next x? 3. Corresponding y? 1. Next x? And 3. I just have my ordered pairs in the table of values. All the x values with their corresponding y values. That's my table of values. You can also see your table of values written horizontally. Same concept though. You just have your x values with their corresponding y values. Just like this. So your table of values can be written vertically or horizontally. Questions on set of ordered pairs or a table of values? I see us writing, so I'm going to give us a little bit of time. Okay, there's a couple more ways we can express a relation. The next one is what we call a mapping. I'm going to write my ordered pairs over here. 1, 2. Negative 2, 1. Three, 1. And 5, 3. Okay, a mapping. I'm going to do something similar as I did with my table of values. I'm going to have all my x values on the left, in the left oval. So what are my x values? 1, negative 2, 3, 5. If I had an x value repeating, I would not write it twice in the oval. I would just write it once, okay? For my mapping. Now, what's 1's corresponding y value? 2. So in a mapping, we say that 1 maps to 2. So I'm drawing an arrow from 1 to 2 to know that those are together. I got my x value with my y value. Okay? What's negative 2's y value? So I'm going to put a 1 over here, draw an arrow from -2 to 1. What's 3's y value? It's also 1. So am I going to write 1 again? What do you think I'm going to do? Just draw an arrow from a 3 to 1. Map 3 to 1, just like that. And what's 5's y value? Is 3 already up there? Nope, so I need it up there. I'm going to map 5 to 3. Everyone see that? So I can have 2 x values mapping to 1 y value for my relations. Or for my relations, I can have 1 x value mapping to 2 y values for it to be a relation. Okay? But for my mapping purposes, if it's repeated in my x's, I don't write it twice, or 3 times, or 4 times. For my y values, if it's repeated, I don't write it 2 or 3 or 4 times. I just write it once. Okay? Questions on a mapping? Okay. The last way I can express a relation is a graph. You guys have seen a graph before. How do you think I'm going to express my relation on this graph? Yeah, just graph all the ordered pairs, right? So my first ordered pair is 1, 2. Let's talk about graphing ordered pairs first. What value comes first in an ordered pair? X. That's my horizontal movement. So if it's negative, I go left from the origin. Positive, I go right from the origin. What value comes second in an ordered pair? Y. That's my vertical movement. Positive, I go up from the origin. Negative, I go down from the origin. Right? So, for 1, 2, can someone raise your hand and tell me which 2 directions I'm going and how many units?
1 up and 2 to the right.
Not quite.
1 to the right and 2 up.
Very good. Remember that x value is our horizontal movement. So I'm going 1 to the right of the origin and then 2 up. So that would be plotted right there. Does everyone see that? Started at the origin, went right 1, up 2, put a point. Can someone help me out with my next ordered pair? -2, 1. Cherry and wrist.
-2 to the left.
2 to the left
Oh, 1 up.
and up 1. Very good. Let's go left 2, up 1. Questions on that one? Can someone raise your hand and tell me the 2 directions and how many units for the next one?
Go to 3. And
Go how many, which direction? Up, down, left, right?
right.
Right 3. And then up 1. Very good. And the last one, just as a class, which 2 directions am I going and how many units?
Right 5, up 3.
Right 5, up 3. And there's my relation expressed as a graph. I'm not going to connect the points. When we get to functions, we'll start connecting points, okay? Questions on that? So what are my 4 ways I can express a relation? Graph, mapping, table of values, set of ordered pairs. Those are my 4 ways to express a relation. Correct? Any questions on any of those ways to express it? Can I move on? Let's talk about independent, dependent variables. You guys have heard of these terms before, correct? Pre-algebra. My independent variables are always graphed on the horizontal line or my x-axis. That's where my independent variable is always going to be. A lot of the times when we're dealing with situations, our independent variable is time. Okay? My dependent variables are always graphed on my vertical line or my y-axis. That's where the dependent variable will always be graphed. So my independent variable, if I'm dealing with x and y, my independent variable is always x. Dependent variable is always y. You've probably heard this before. A dependent variable depends on an independent variable. That's why we call it dependent. Does that make sense? The outcome of that variable depends on the independent variable. Right? Any questions on independent, dependent? Okay. We're writing it down, right? Give you a little bit of time. Okay, let's move on. I'll come back to that slide if I need to, like I said. Okay. I'm going to give you a scenario. I'm going to ask for volunteers to give me the independent variable in that scenario and the dependent variable in that scenario. Okay? So, scenario number 1. Let's say I work down at Freddy's over on Douglas. Most people who work in fast food make an hourly wage. Does everyone know what that means? Okay. So, I get my paycheck maybe every 2 weeks, maybe once a month, something like that. Right? Can someone raise your hand and tell me what the independent variable is in that scenario?
My hours to work.
Very good. Number of hours worked. Can someone raise your hand and tell me the dependent variable?
When do you get paid?
Very good. The amount of my paycheck. The amount of money I get on my paycheck depends on how many hours I worked that 2 weeks or that month, depending on how often I get paid, right? So everyone see how that independent, dependent variable works there? Questions on that scenario? Scenario 2. Some of you guys might be driving, some of you may not be, but you're close to it. You get a ticket if you go too fast, right? Is there just one set price for speeding?
No.
It fluctuates, right? So what would my be? Raise your hand if you can tell me my independent variable there.
How fast you're going.
Very good. My speed traveling. Raise your hand if you can tell me my dependent variable.
So the amount of money you get paid. I mean, the amount of money you owe.
The amount of money I have to pay, right? The price of my ticket. So the amount of money I owe, the price of my ticket, depends on how fast I was going past the speed limit, right? If I'm going 10 miles per hour faster than the speed limit, my ticket's going to be less money than if I'm going 50 miles over the speed limit, right? So the price of the ticket depends on the speed I was traveling. Questions on that one? Okay. We've gotten some rain past couple of days, haven't we? We're about to get some more rain. What happens to the grass as we get more rain? Well, it gets wet, but the grass grows, right? So, what would be my independent variable there? Someone raise your hand.
How much it rains?
Very good. The amount of rainfall. So what would be the can't talk. What would be the dependent variable there?
The grass. Speed the grass grows at.
Speed the grass grows at, or the height of the grass, right? The height of my grass and how fast it grows depends on how much rain we get. If we get a lot of rain like we've been doing, my grass is growing pretty quick and pretty tall, right? I'm going to have to mow pretty soon. But if we're not getting a lot of rain, like before, was it 2 days ago we got rain? Sunday night? Before Sunday night, my grass wasn't growing very fast or very tall because we barely got any rain. Unless I watered it. But that's besides the point. We're talking about rainfall here, right? So, questions on that scenario? Okay, next scenario, still talking about cars. What makes a car go vroom vroom? Gas pedal, right? Well, just gas in general, but if I push the gas pedal, it makes it go vroom vroom, right? The harder I push on it, what happens? Faster it goes. If I let up off the gas, what happens? It slows down, right? So raise your hand if you can tell me my independent variable there.
The pedal thing.
Pedal thing?
Yeah.
The amount of pressure I apply to the gas pedal, right?
Yeah.
So pressure to gas pedal. Raise your hand if you can tell me my dependent variable.
How fast it goes?
Very good. Speed of the car. So how fast I'm going depends on how hard or how hard I'm not pushing the gas pedal. Like we said, the harder I push the gas pedal, faster I'm going to go. If I take my foot off the gas pedal, it's going to slow down. Everyone see how it depends on another thing? Questions on that scenario? Okay, last scenario. Algebra 1 class. You get a grade in Algebra 1, don't you? How do you get a grade? Or how do you get a good grade and how do you get a bad grade?
If you don't do your work.
Very good. So, what could our independent variable be?
If you do your work.
So our effort in the class. We could say effort, right? Bless you. Effort in class. And outside of class. What would my dependent variable be here?
Your grade.
Grade in Algebra 1. So, if you're turning in your work, you're paying attention in class, you're not on your phone in class, you're studying for the tests, you're asking questions if you don't understand them, you're not sleeping in class, you're probably going to have a pretty good grade in my class, right? But if you're not turning in your work, you're sleeping in class, talking when you're not supposed to be talking, on your phone, you have headphones in all the time, I'm constantly telling you not to do that. You're not studying for tests, you're not asking for help when you don't understand something, you're most likely not going to have a very good grade, are you? So my grade depends on how much effort I'm putting inside and outside of class. So everyone see how that works?
See.
Question?
If you like fail like classes in ninth grade, do you have to take?
Ask me later. We're in the middle of the lesson.
Yes.
You just get to retain.
Any questions on our independent, dependent variable little activity here?
See.
Everyone understands how dependent, independent variables work? Our dependent variables depend on our independent variables. Okay? And it's not just in math, is it? That applies outside. Boom, application problem right here. This is how math applies to your everyday life. Independent, dependent variables. Okay? Can I move on? I got a worksheet for you. Are there any questions before I end the recording about my notes?
You're running a fine line.